Hello all, good morning. This is Dr. S. Lakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the most differential equations and transforms, and now we are on to the topic of Laplace transforms. In the previous videos, we have discussed problems regarding the properties of Laplace transforms, and we have seen some of the transformations of elementary functions also. Now also we are going to see some elementary transformations of Laplace, wherein we have the function like L of f of t divided by t. In the previous videos the t was in product with f of t, but here it is divided by f of t. So what it should be done for the Laplace transforms? It is to be taken up as integral s to infinity f of s ds. What should we do? We have to find this f of s and we have to integrate it with respect to s within the limits s to infinity. That is what we have to do if we have a t in the denominator of the given function. So what is the first problem is L of 1 minus cos t divided by t. As you can notice that you have a t on the denominator. If you have a t on the denominator, as usually you will go on with this rule. What is it? Integral s to infinity f of s ds, which means L of f of t ds. So integral s to infinity L of, what is the given function here? 1 minus cos t ds, which is nothing but integral s to infinity. We are just going to split this into 2, L of 1 minus L of cos t ds. We are going to integrate it with respect to s. Now what is L of 1? As we have discussed earlier, it is 1 by s. And what is L of cos t? It is s divided by s square plus 1 into ds. What is the limit of integration here? It is s to infinity. Now what is the integration of 1 by s? It is log s. And what is the integration of s divided by s square plus 1? Here is a difficulty arises. On differentiating this, you have 2s plus 0. You will have to have 2s for integrating it. So if you want to have 2s here, you will have to multiply 1 by 2 or 2 multiply by 2 and divide by 2 on the same term here. So what you will have 1 by 2 here, and therefore on integrating this you will have log of s square plus 1. I hope you understood. You have to have a 2s on the numerator so that it can be changed to log of s square plus 1. For that matter, we are multiplying by 1 by 2 here. Therefore, this will become log of s square plus 1 as the integrated value. What is the limit here? S tends to from s to infinity. What is the upper limit? It is infinity. What is the lower limit? It is s. Now we are instead of applying the limits directly to the function here, we are doing some sort of manipulations to get that s on the denominator, since we have an upper limit as infinity, so that we will take up that value to be 0. So our ultimate aim is to bring all the s's to the denominator only. So for that, this is taken up like this: log s minus log of this. We have a log rule. Log of a log b is equal to log of b to the power a. In that matter, we have just taken this 1 by 2 to the power of the value, which is log of s square plus 1 to the power 1 by 2. What is its limit? Its limit is s to infinity. In the next step, what have we done? We knew a formula for log, which is log of a minus log of b is equal to log of a by b. So this is what we have done here. A is s and b is s square plus 1 the whole to the power 1 by 2. Within the limit s to infinity. I hope you understood like this, and we will move on to the next step. What have we done is we will take this numerator to the denominator, or we will change the denominator as what is to the power 1 by 2. It is nothing but square root of s square plus 1. That is what we have changed. So the value becomes log of s divided by square root of s square plus 1 within the limit s to infinity, which is also equal to log of, I am bringing this s to the denominator so that it will become 1 by s on the denominator into root of s square plus 1 within the limit s to infinity. All the other things remains the same. The only thing is we are bringing this numerator to the denominator. Now what we are doing in the next step is we are taking just s square outside the brackets of this thing, so that this will become like this. On taking the square root and bringing this s square outside, so we will have x here. So that is what we have done here. We have taken s square outside the square root so that it will become s, and into square root of 1 plus 1 by s square within the limit s to infinity. Now in the next step, what have we done? This s and this s will get cancelled. So this will become log of 1 divided by root of 1 plus 1 by s square within the limit s to infinity. And now also we have got that s to the denominator, and this will become infinity. And now, as usually, we will apply this log a and log b formula here. So this will become log of numerator minus log of denominator. So, in the next step, what have we done? We know that log of 1 is 0 and log of 1 divided by root of 1 plus 1 by s square within the limit s to infinity. Now, we can apply the limit here. What is our upper limit? Infinity have been applied here. What is the lower limit? It is yes, it has been applied here. Now, what will be this value? This value becomes 0. So, 1 by root 1 is log 1 is 0. So, all the other terms remains the same. So what is the final answer here? Log of 1 divided by root of 1 plus 1 by s square. So what is our problem? Our actual problem is to find the Laplace of 1 minus cos t divided by t. And this is nothing but the value that log of 1 divided by root of 1 plus 1 by s square. So this is how we find the solution. Thank you.